Distinguished guests, a very warm good morning and a very happy new year. Team Shikhar is here today to present a case study on achieve quality excellence in electrical inspections through FTR approach. So pack your bags and get ready.
So this is the content of our presentation. We'll start with the introduction of our organization and team, thereby the selection of problem, then we'll solve the problem using the DMAIC process of LQC, and finally we'll show you the updated milestone chart. So we'll see what is L&T. L&T is an Indian multinational that is engaged in EPC projects, high-tech manufacturing services. It has operations in over 50 countries and has multiple divisions. L&T Defense is one of them.
L&T Defense is a torchbearer for Atmanirbhar Bharat. It has 2 dedicated R&D centers, 3 design centers and 6 production centers. VPC, that is Vizag Production Center, is one of them.
And coming to Vizag Production Center workflow, here the drawing release and construction happens in 3 main domains, that is structure, engineering and electrical. So we start with fabrication of panels and outfitting, and thereby the board formation is achieved.
At Vizag Production Center, we are working on a mammoth object which contains 16,500 of equipments, 30,000 of pipes, 15,000 of cables, and we are dealing with more than 500 OEMs.
We started our quality certification from 2011 and we have obtained various level of quality certifications. Coming to FTR, we started our FTR journey in the year of 2018, and Vizag Production Center is the first unit who has implemented the first and rate concept inside around across L&T Defense.
Introduction of Team Shikhar. I am Kuldeep Rajpal, leader Team Shikhar from Quality Department.
Myself, Vaisandhya from planning function.
I am Pritam Bose from production.
I am Balaji from design.
I am Ashwin from IT and Distillation.
I am Karnasari from QAQC department.
The balance details of our teams are as shown. So now we'll see the problem selection process. In that, we'll first start with the intro of FTR, then followed by how the problem was selected. The tools that we use are flow diagram, brainstorming, vision matrix, pie chart and bar graph. So our quality guru Philip Crosby brought the concept of 0 defects. Hence, it is to do it right first time. So before we dive deeper into the process, let us watch a small video.
Let's face it, there is no safety net in our daily routines. We may do our job, try our best, meet all quality standards, but still, if we don't do it right the first time, we lose precious time, our reputation, raw materials, financial resources, and can even harm our patients. Bottom line, mission failed. Right first time is a culture of excellence comprised of a mindset, a way of acting, and a practical toolbox that creates an atmosphere in which teams and individuals perform always right the first time. RFT is our safety net. Let's start using it right now.
The primary goal of FTR is
Defect prevention in first place.
FTR encourages organizations to
Continuously evaluate and improve the process.
FTR is key enabler for.
Efficient project management and improve customer confidence.
So team, what is FTR?
Do it right.
The first time,
Every time.
On time. Now we'll see how FTR is calculated. Say there is a shop floor that produces 10 items. Out of that, if 8 are accepted and 2 are rejected, FTR is simply 80%. Now that we have seen the calculation, we'll see how the FTR workflow is.
As we understood the calculation methodology, now we will take you to the workflow. As the job is ready, the portion they will offer the inspection to QC. If the QC checks is satisfactory, then inspection is approved. If the QC checks are not satisfactory, the observation ported in the database, where the database is used for capturing the real-time data analysis, and we can view the top management reviews and take appropriate actions.
So in one such top management review, the FTR dashboard was analyzed. It was found that the site level FTR was lower than the review target of 97%, and the low electrical FTR was impacting that unit level target. So management wanted someone to focus on the electrical FTR, and hence the genesis of Team Shikhar took place. So once having formed the team, we analyzed the stages which are getting offered in electrical and found that there are 5 stages which have the highest volume in electrical, and they are namely shop checks, route survey, laying, cable connections and weight measurement, and the respective rejections are like this. So we used a decision matrix to identify which stage to focus on. So team, can we focus on shop checks?
No.
Why?
Because Because rejection is low.
Control on task is low.
Should we focus on laying cable connection weight measurement?
No.
Why?
Rejections are low.
Should we focus on root survey?
Yes.
Why?
Because volume is high.
Rejections are high.
Control on task is high.
So we see that improving root survey FTR can be considered as a problem statement.
So, after selection of the problem, now we are moving into the first step of problem solving technique, that is define phase. In define phase, the tools we have used are flow diagram, pictorial graph, Gantt chart and milestone chart.
Friends, let's understand the electrical workflow through high level flow diagram. It initiates with the drawing release and material finalization, which opens up two parallel paths, that is equipment installation and cabling installation. These two converges into cable connectation, followed by readiness checks, trials and commissioning. We have also understood that cabling activities is having high number of defects, so we felt the need to drill down further. The cable installation workflow is like this. It initiates with the cable anchor installation, followed by root survey and following process. We have also analyzed that root survey is having high number of volumes and high number of defects. Hence, it is evident that root survey held-ups is choking up the entire workflow, and it is also we can conclude that it is critical to penetration trials and commissioning. So friends, why root survey is important?
Because it ensures cable load correctness.
It ensures correctness of templating, hence cable cut length.
It ensures cable on time.
It ensures cable route readiness for laying.
Having understood the qualitative importance of root survey, we have also analyzed the data part, and we have found that the root survey FTR is quite low, that is 78.5%. So we have targeted that we will achieve 90% FTR in Q1 of 2023 to meet our overall site level target of 97%.
The redefined problem statement is improve first and right in root survey process from 78.5 to 90% by 15th Feb 23.
We have also chalked out our milestone chart to make it in a time-bound manner, and here it is.
So what is now? We have defined the problem statement, project objective and the scope of work. Now we are moving from define to measure phase. In measure phase, the tools we have used are bar graph, pie graph, line graph, brainstorming and Pareto chart.
With the information available in the FTR dashboard, we analyzed based on the pie chart and line graph that the FTR has got low in the design function. And also brainstorming session was conducted, and it got to know that there is a root survey. Between the root survey and the design process, there is a strong linkage with respect to the observations that are coming in the design function. So Pareto was drawn with respect to the design observations, and we got to know that there are top 4 contributors, and these are
Data mismatches in 3D PDF drawing,
Bill of material constructions and updations.
Mismatch between interface drawing data.
Now there is a mismatch in design data. So after selection of the problem, after identifying the top 4 contributors, now we are moving from measure to analyze phase. In analyze phase, the tools we have used are flow diagram, relationship matrix and 5-way analysis.
So before understanding the root causes, let us dive into our design data. So here we have n number of attributes in which one data is interlinked to one another. Thus, there is a requirement to make every data into intelligent, connected and programmed into a single platform, that is called UDD, which is Unified Design Database, so that entire thing can be automated. So coming to the design release flow, so here we have customer driven drawings, thereby we prepare 3D model and derive 3D PDF drawings, and the entire information is released into product lifecycle management through UDD. So any change in one attribute requires a trigger for change in all the attributes. So having understood about the data, so let us conduct a 5-way analysis for the root cause of those contributors. So first one is data mismatches in 3D PDF drawing.
क्या
Incorrect data is captured in protocol.
एरकम क्या
Incorrect data is there in PLM.
क्या
Because incorrect data is fed from UDD to PLM.
किंतु क्या
Data in UDD is not matching with model. Because there are gaps in data sync issues between 3D model and UDD.
Understood.
And coming to second contributor, that is bill of material corrections and updations. Because incorrect inspection data is captured from bill of material. Because latest changes are not updated in the BOM. Because changes are updated incrementally and they are not in line to the plan. Because there are gaps in change management process.
Understood.
And coming to third contributor, that is mismatch between interface drawing data.
Why?
Because captured inspection data is not matching with interface drawings.
But why?
Because latest interface changes are not updated in BOM.
So why?
Because change in one drawing is not reflecting in all the relevant drawings.
Then why?
Because interface changes are not in line to the plan.
So finally why?
Because there are still gaps in change management process.
Understood.
And coming to fourth most contributor, that is nomenclature mismatches in design data.
Q,
Because incorrect inspection data is captured in bill of material.
Q,
Because nomenclature in BOM is not as per interface drawings.
per Q,
Because it is as per installation drawing.
fit Q,
Because nomenclature check is not ensured during initial release of drawings.
Q,
Because there are gaps in interface validation checks.
Understood.
So here we go with the summary of all those top four contributors and the respective root causes.
So finally, what are the root causes? What are the root causes identified and what are the controls? So now we are moving from analyze to improve phase. In improve phase, the tools we have used are brainstorming, flow diagram and bar graph.
After
identifying the root causes, we have done a brainstorm session and identified the various solutions. We have finalized the solutions based on the effectiveness and resource requirement. Highlighted the 3 other solutions that we have finalized. The details are shown below.
How data sync issues are addressed?
It was addressed by doing the daily data migration from model data to UDD, and we are doing a PLM checks daily.
And how the gaps in change man process are addressed?
It was addressed by changing the root survey inspection workflow by introducing checks, by introducing plan and checks prior offering of inspections.
And how gap during interface validation is addressed?
It was addressed by doing a proactive checks between the electrical installation drawings and schematic drawings with respect to the interface changes. We have done a pilot implementation of these solutions in December 22, and we found the root survey of has been increased by more than 90%. So we have done full-fledged implementation Jan 23. Our team Shikhar journey started where the site level, unit level FTR is not achieved because of electrical FTR followed by design FTR and root survey FTR is low. So we have done, after implementation of the solution, the result is moved from bottom to up, where our root survey has increased by 10.6%, design FTR has been increased by 9.7%, electrical FTR has been increased by 1.6%. Thus, we have achieved our unit level target of 97%. Apart from the FTR improvement, there is a tangible benefits from this implementation. That our progress of root survey has been increased by 147% and the cable progress has been increased by 94%. And we have a cost saving of more than 10 lakhs per month potentially. And the cost saving details as shown, where we have calculated how the cost to be taken for the cable routing process, and it's around for one cable it's taking 3,000, and the calculation is part like it is coming around 10 lakhs per month. And intangible benefits are
Improve customer confidence.
Improve team morale.
Increase workman satisfaction.
So finally, having implemented the improvements, now we are moving into the control phase. In control phase, we are going to explain how we are holding the gains and ensure our sustainability. So we have established the SOPs with respect to the UDD checks and change in workflows, and also we are conducting the monthly review meetings with the top management as per the stage-wise, function-wise, and area-wise.
Thus, we control our project, and the updated milestone chart is as shown. We have completed well within the time. The way forward for our team was improving root survey FTR now beyond 95% and improving electrical FTR beyond 97%.
Before concluding, we would like to thank our management and the NCQC team for giving us this opportunity. So before completing, we would say journey of 1,000 miles begins with a single step. Thank you.
Team Shikhar.